If a child is to keep alive his inborn sense of wonder, he or she needs the companionship of at least one adult who can share it. Read this system that happened right here in Lake County, on this lake. They used DDT in order to kill the black gnat, and it biomagnified up the food chain, which you'll hear about tonight, at least the food chain, and it killed off the grebes. And so we're well rooted in that. Kelly, we just handed out the test.
Oh. I missed it.
Does anybody know Rachel Carson's profession?
She's an interesting one.
She was a marine biologist. And that was my first field, was marine biology. Well, I read a lot of Rachel Carson. Read a lot of Aldo Leopold because I also got into forest ecology, and that's everywhere. And the other one is Gifford Pinchot, who did a lot of forest ecology stuff. And Aldo Leopold actually worked in the Forest Service for a number of years. And they didn't get along because they wanted to cut trees, and he wanted to tell them how to cut trees. It's not about cutting trees. That's a good thing. That can be economical. It can be good for the forest, but not the way they were doing it. And so they all parted ways. But I have I went looking for a quote because I wanted to use it on one of these slides. And I thought it was Rachel Carson, so I got all my Rachel Carson stuff out from the internet, right? And I realized it wasn't her at all. Then I had to figure out who it was, and it turned out to be Aldo Leopold. But I had a lot of this stuff memorized at one time. So I'm going to read it when appropriate, if I can find it again now. 1 minute. Land is not merely soil, it is a fountain of energy flowing through a circuit of soils, plants, and animals. You can't get any better than that. So we'll talk about that circuit tonight.
I see you outgrew the regular classroom.
Huh?
You outgrew the regular classroom.
Yeah, I ran a lot of people out. I see a lot of people that said they were going to be here, and they have signed up for the whole series. And I have an idea that we're going to get some add-ons, and I kind of wanted to catch this first slide with them. There's a problem with putting too much into the first slide, is because if anybody walks in late, you kind of lose them on this stuff. But it's right at 7 or 2 minutes after, something like that, 7 now. I'll start right on this thing. In fact, I'll start now. I'll get you to think about it. Hi, Beth. We talked about climate and geology last time, and this time we're going to talk about ecology. So now with the understanding you have, or whatever you could remember, because I just skipped across the knowledge of climate and geology like a flat stone across the lake. So I was just skipping over principles. But even with those principles, you can interpret this and realize why ecology works. So you have to think. Well, I gave one guy the answer already. You should be raising. Jeez, I gave you the answer already.
No. Oh, am I supposed to answer that right now?
Anyone can answer it.
Well, what was the question again?
Life.
We talked about the Earth circling the sun in the habitable zone.
It's the Goldilocks zone.
Goldilocks zone. Not too hot, not too cold. Right here is just right. What is just right? So I didn't want to get into too much detail last time, just to say, hey, listen, we're really lucky because look at everybody else is left out. Mars is in the habitable zone, but there's a reason why Mars didn't benefit for that very long. So I didn't want to talk about Mars, I want to talk about the Earth. So here we are talking about the Earth, and it's in the habitable zone of orbit around its sun, its star. And that's why they're looking out at planets around stars now that might be in, a habitable zone. And the reason is Because the temperature will allow
Liquid water.
A vapor and solid.
all three forms of water. Everywhere else you look, they're in a solid form, unless they're in a vapor form, unless you're here. And that's the only place you're going to get any liquid water of any significant amount. There's even water on the moon. And that's just been discovered recently. Oh man, I'm telling you, it's the age of discovery. There's water left on Mars, but it's only in solid form, except maybe it'll be in the soil somewhere. But you don't have any oceans up there. It used to at one time. Got a lot of indications that it used to be there. It lost its magnetic field, and so it lost its water. We have a very strong magnetic field. And so that magnetic field is a result of being large enough with enough gravity so that our iron core will be a solid at the center, but will be moving around that solid core where the gravity is less. And it will be moving because of the spin of the Earth. It'll also be moving because of convection currents bringing the heat to the surface and back down again. And so that actually moves the surface around because the surface is like the skim of chocolate milk over the top of liquid. And so it's moved around by that convection current. So when you look at this slide, what do you see now?
Three forms of water.
You see that we're sitting in the subduction zone of one plate underneath another, and the material that comes at the heat at the bottom of that subduction zone of the plate, with all of the gases that it produces from that heat and the water and the rest of it, comes to the surface and produces a volcano. So the volcano is right there in a crack line, and it's right in front of us, and it says, aha, we're right where the subduction zone was. What's the significance of that? If you were to look at the Earth from the standpoint of all the key elements of life, most of them are in the Earth that's moving around, not in the part that floated to the top. Very few of the, maybe half or less, of the key elements of life are actually on that surface that's floating around. So you've got to have the rest of the stuff come up somehow, and it comes up through the volcanoes. Lake County has all of the key elements of life, which are carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Those 6 elements produce the biomass of 98% of the life forms on this planet. And that's the reason why, the rest are those that don't use oxygen. But the reason why that's so important to scientists looking for life somewhere else is that those are the ones that they're going to look for, and look for them through the spectrums of the light that comes to Earth. And so with all that said, we've got all of those right here. Unfortunately, we have a little too much abundance of the phosphorus and sulfur part. And it gets in the lake, and then of course you can get a lot more life form than maybe you want, or maybe you would like, because you're human and you judge everything. But the life forms like it. This is really a viable, amazing lake full of life. And sometimes it smells because it's going through that cycle, sometimes not. Too bad, they like it. But that's what you're looking at. So you've got this volcano delivering these gases back into the local environment. Phosphorus comes up, lays out into the soil. The soil runs off as erosion. You get too much erosion, you get too much phosphorus in the lake. We have carbon, of course, has valence that attaches to a lot of other chemistry. And so, in fact, it's central to most of the chemistry in a living life form. That's why we're carbon creatures. And if we look somewhere else, the only other thing that you're going to find is either a carbon creature or a silicon creature. If you're going to have any kind of life form that could develop far enough that you can run, think, do all the other things. And otherwise, you take those elements apart, you're not going to have much. You're going to have lower life forms. So that's why they look for carbon-based critters somewhere else. If it's got carbon up there, maybe something's going to happen. Too much carbon, maybe not so much. So the other thing you're looking at is those 3 phases. Now, on those 3 phases of water, you got the liquid form, the liquid form down here that basically, if it's clear, the sunlight can penetrate, and the sunlight is the source of all life on this planet. You're not going to have life unless you have a source of energy. The only other sources of energy are chemical energy. That would be at the bottom of the ocean, where you have volcanoes coming up there, and you have a liquid around it. So anywhere you have energy, you can look for life, but basically, unless it's an extremophile around a vent, it's going to wind up to be in the water or associated with the water, and it's going to have the sunlight driving that life. So we have sunlight here, but it actually will warm up the atmosphere. The more it warms up the atmosphere, the gas of the water will then be absorbed by the atmosphere, because as the molecules spread out, it allows for more water to be sucked up. It's like a big sponge. And so warm air is going to have more water. And then if it squeezes down and gets a little bit cold, you'll start to see that vapor, how much water it had, and it'll be a cloud. So now you're looking at the gas, which is in the atmosphere. And that's what a cloud is. Up here, oh, and I got to say, clouds are reflective of sunlight. So anything that comes in will bounce off the top. It will also hold in heat. It is the original insulator for the earth. Any warmth that comes up will be contained and will also be captured by the moisture itself. Water is the great absorber of heat. And that's what you learned last time, was all of these things that drive the earth is from the ocean moving around because of the spin, because of the circulation of those heat to the north and the south. We can have life just everywhere on the planet because of that circulation pattern. So water holds the heat, and it also reflects off the sunlight. If there's too much cloud cover, it starts finally to get cold underneath. Otherwise, it's still trapping the heat. Up here we have the snow. The snow is the solid form for us. If it's ice, it's even better at this, and that is the sunlight will really reflect off the snow. This allows for the snow to warm up and melt later in the year, because it takes longer for the sun's work to actually heat it up, to either go off as sublimation, which is where the ultraviolet will come down and take the snow off as gas, directly into gas, and won't go into a melt. How do you think we lost the glaciers, the big glaciers? We talked about the Ice Age. That was through sublimation. I'm going to show you another picture of what the aftermath of that is. But right here you have this reflective hood on it, but these mountains aren't high enough. If these mountains were up above the 4,300 feet above sea level that they are here, and up double to that, then you might have had glacier. And so last week we learned that we didn't have glaciers here. And there's no form of glacier in Lake County, or in the coast for that matter, until you get up to the Klamath, then you have glaciers. The other thing to look at here is you do not see any erosion. There's no erosion on Mount Konocti. It's because it is one big cinder cone of cracks and fissures and loose incorporated rock and ash. It's mostly silica, but there's a lot of other elements in it. And there is, in fact, such a porous cone here that it will seep down and come out on the lateral side and some on the edges of the lake. The lake itself has got such a seal on it from all of the sediments that it doesn't actually come out like a spring. Haven't found one yet. There's a couple of small springs, but not very much, and don't go very long in the year. It comes out through the sides. Cold Creek on the backside run is a very small watershed. And for some reason, it runs all year long practically. Right? Okay. And so that's the reason Cold Creek is so popular with the natives back there and the rest of it, is because you can always get water, can always be fresh, and it is highly filtered because it goes through this big cone. You have vents. These vents actually brought the gases up. The pressure from all these gases, this is such a porous fissure in the earth that it was coming up everywhere, and it never built any pressure behind it. So you don't have the explosive pressure that you might in some areas like St. Helens. But here, it came up like toothpaste and just made out layers. You can actually see when especially when you get a little fire, you can actually see on the backside layers of excrement out of the top. The vents are still there, and the vents, after this whole thing quieted down, and by the way, it's still an active mountain, you can still get some pressure. Sometime in the future, we're going to get pressure out this again because these vents, these cracks in the earth are pretty deep. But it's going to be something that'll make a nice sunset. It's going to be beautiful. People will, yes, it will be, I swear, it's got to. People will come from San Francisco, all over, they'll come here and see us.
Poor Buckingham.
The vents are still here, and in fact, one vent right near the top of Wright Peak, off to the side and in the backside, used to be visited by the people who lived on the mountain and lived there. After the Native Americans, they moved up there. Native Americans didn't have too much to do with the top. They considered the sounds from the mountain and things like that to be a problem for them. But in the back on the side, there is a vent. It used to be accessed quite a bit. You could get in there, go down, and then off to the side, and then down. So people would go in, go off to the side, and whoa, it's dark. I don't know if anybody ever fell in, but if they ever did, they're still there. And they would drop rocks and listen. So one some kids went in and went so much string with them that surely it will be able to hit bottom. So they dropped their rock with string. Ran out of string. 1,100 feet of string. They brought it back and measured it. Because they thought wherever it was going to hit bottom, they were going to tie a knot, come back and measure it. Ran out of string, so they brought it all back. 1,100 feet. The mountain itself from down here is about 2,000 feet of gain. So you got a 1,300 foot lake and you got 2,000 foot of gain, and the mountain is 4,300 feet. Wow. So they were only halfway down. You can, by looking at it, see what happened to the mountain over time. On the side right here, see how this looks indented? Imagine a vent right there. Imagine a balloon. The balloon loses some air and inflates a little bit, deflates a little bit. See that deflation? This is not a landslide. This is a huge deflation. And the deflation is the whole thing falling in. You would see where it went. Otherwise, you don't see where it went because it didn't go anywhere. It deflated. And so that explains this entire cone. And this here that holds the whole thing up on the sides is where the ash hardened. So the ash hardened, and the rest of it that came in and deflated and then washed away was ash. So what was left to expose to the air basically hardened. So you're looking at the bluffs of that hardened area. There's a little lake down here that's part of that vent system. So if you were to take that all the way out Buckingham, you would say that, oh, well, that's where the landslide was, and it all went out and formed back Buckingham. You're not going to get a geologist in this state to agree with you. That's all independently formed. Independently formed fissure that formed Buckingham all the way through Canocti, all the way along the backside of Canocti, all the way down to Thurston Lake. Thurston Lake is a big vent. And there are some people that believe that all of that's connected with vents, and that's just the place where it all collapsed in. So there's not a lot of knowledge that pins this together, but this is the belief right now where this explains the way this whole thing operates. The oldest historian that I could read about this called it a ventilated or an air-conditioned mountain because there's talk about caves on the side where the air would pull, the cave would pull in air, and they would put smoke at the entrance to the cave. It would disappear and it wouldn't come out anywhere. They couldn't find it anywhere, and smelly smoke, burning tires, it didn't make a difference. Could not figure where it went. In any case, that's been closed off. It's over in the park, Clear Lake Park. So there are people over there who may know about it. I've only been there once. It's all kind of caved in, so you can't tell much. But under the right conditions, you can see the air move towards the side of the hill. So in any case, that's the mountain. There's what you would learn. You would look at this and you would say, Clear Lake and Lake County has got all of this geology going on right here under your feet. You've got a huge fault block that drops out, well, out that lake right there, the upper end, that basically forms that. We learned that last time. And right here, two arms that actually sit on top of faults that 40,000 years ago for sure, those were not part of the lake system, lake ecosystem. So anyways, that's the first slide, and that's kind of your recovery from last week as to how you can interpret now where you live. Now, if you take the snow and the gases away, you got a different interpretation here. We're getting more and more into ecology. Ecology is living on the non-living landforms with all the other non-living things that influence you, and then it's the study of life and how it adapts to all that. And all you have to do is look at this and you say, wow, what happened right there? Well, because of the shape of this bowl, it captures a lot of water. Because of the mountain being so porous, a lot of water is in behind it. And so right here is a remnant forest of back when the county had more moisture, which we're going to see why here in a minute. But the county at one time had more moisture, and the Doug fir was the dominant species. There was also redwood here. When you go up a little bit higher, a little more towards the coast, and you get more fog. But and there's a reason for that, but you'd have to study redwoods. But anyway, Doug fir is very well suited for this area, and so we have a lot of Doug fir. Nothing stays the same. Everything's been changing, and this mountain is no different. It wasn't so long ago. The entire mountain was covered in Doug fir. You don't see that anymore. There was a lot of, by the time they came to logging, it wasn't there. I don't know that the mountain was logged. But what you will find is the Doug fir has remained for now. And right in here, you're getting more pine, and it's Pinus sabiniana, great pine. You're getting more gray pine. They used to be called digger pine. And so you're getting more of that coming in here. And also over here, you're getting a different kind of pine. This is knobcone pine. So knobcone pine is much better adapted or more adapted to a xeric condition or dry condition and fire. And so we get a lot of fire, we got a dry condition, you're going to get more knobcone pine. And sure enough, all of a sudden, knobcone pine started showing up above all of the brush over on that slope. I was watching for it. Next thing you know, it was there, and it's everywhere now. So lots of knobcone pine, lots of gray pine. We still have the remnant Doug fir. Unfortunately, though, right there is a patch of knobcone pine that's starting to come in. It's all going to disappear.
So is Doug fir the Black Forest? Is Doug fir the Black Forest?
Yeah,
Okay.
Doug fir is the Black Forest. We just had a fire over there. Back in 1650, when they sailed around the world and discovered the California coast, several things that you learned last week we're going to apply now. There was a current that came down the coast called the California Current. There was a big high-pressure system that sits almost permanently here, and so the winds would be sweeping down this way. If you're in a square rigger boat and you're coming up the coastline, you're not going to get too far. Many attempts, it takes you 100 days, and then you're only that far, and you're running that, oh man, mutiny on the Bounty is going to happen. Listen, we've been sailing for 2 years. You get us here in these headwinds, and all I have out here is, this terrible coastline. So they got to, this is probably Monterey Bay right there, and there's several people that did this, Cabrillo, and I can't remember all, and they also went up the Gulf of Baja, and what they call it, Sea of Cortez. And so California was shaped out this way because when they got back, the cartographers would take the ship's log and take all the notations, and they would say, this is what the land looked like where you were. And they would say, wow, it's an island. This is 1650. This is from, I think, 4 ship logs. And so this became the understanding of what California was in Europe. And so there was a popular romantic novel of 1650, and in that romantic novel, super popular, it was about a mystical island called California. So we are named after a romantic Spanish novel of 1650, and that's how California got its name. What I believe is that the cartographers were really aliens, and they were projecting what California is going to look like in 10 million years. And we also talked about that last time. So that's really what's going on right there. This is what California looked like at the time of contact, 1650. They were able to piece all this back to satellite photo. Then they doctored up to look like what it used to look like back then. It looked like this back up until the 1800s, and basically what you had was a lot of water in the Central Valley from all that snowmelt, and so there was a lot of tule elk that was down in here. The crisis for the tule elk is when they started farming all this and you didn't have the standing water anymore. So lots of water all the way up. In fact, I remember accounts of the Stockton area up to Sacramento. It was all clearly sailable with sailboats until the water tables went down. But there's the story right there. That was called the land of perpetual snow. Right up when the Donner Party came over, the books that were written back at the time, I found several historical accounts of the miners, and prior to the mining, it was the land of the perpetual snow. Why was there so much snow? It's because there was so much moisture in the atmosphere. Why so much moisture in the atmosphere? Is because the sublimation of the ice sheets, and they were going off as gas. That gas takes a long time before it gets out of the atmosphere of the Earth and comes down, because it is swept up into these high relief zones and drop out as snow. There's no reason for it to drop out as snow unless that happens over a landform. And so that's why you had this snow for such a long time. We have been drying out as well as warming up. So basically, when you're looking at everything that people are talking about any of the other features, it's about drying out. And you don't see much snow in this era anymore, unless you get a big snowfall. It'll, 2 years, and then it's all gone again. But it was the land of perpetual snow for hundreds of years, well, thousands of years prior to that. EJ walked in just in time. I'm going to mention that I have a quote. The oldest task in human history is to live on a piece of land without spoiling it. Aldo Leopold. And there it is. These people have been living here for thousands of years. When they finally got here, probably earlier than people really imagined because of what we described last time. But what they did was they moved into all of the niches. We're going to talk about niche, but they moved into all of the life-giving niches of the state and were stable for years without spoiling the land. And of course, then the Europeans came, but they didn't see these natives here this way because there was so much pre-contact and post-contact diseases that lowered the populations. So they thought the land was unoccupied, but the fact is it was well occupied. California, I'm going to skip up to 200 years. There's a lot of just really great history to be read, depending on your point of view. But 1850, when California became a state, that's all the counties that were required to be formed in order to manage the land. The state has representation at the federal government, and you manage the land with the counties. There's over 3,000 counties in the United States to do just that. You will notice our county here. Oh, wait a minute. No, you won't. Our county isn't even on there yet. So you have to go a little bit further. There's a lot of politics, some pushing, some shoving. And you get to 1907, you had several counties that went extinct. Some of those you won't see anymore. And you have several counties that they proposed and never got enacted. And finally, you got your 58 counties. And Lake County is now christened. And we are what I call the Orphan County, because nobody wanted to go over the mountains. We talked about the pressure of plate tectonics making all the wrinkles and all of the mountains. Well, nobody wanted to go over those mountains to the county seat in order to file a claim and a land purchase or anything that make anything legal, because you had to go over the mountains. Did I say that? And nobody wanted to come back in to collect the taxes because it's just too far and there's not enough there. And so we became the Orphan County. They took a little of Napa, they took a little Mendocino, just a smidge of the rest. And next thing you know, that we're formed along the ridge tops, and we have our own little county as a result. So we're the Orphan County that nobody wanted. As far as I'm concerned, that makes us the better county because we got all these neat features. They just didn't know about it. So now, what forms what's there? What about all of the biology that lives there? Probably the greatest thing that you can take away from any thought process is, and I'm trying to get that part about the moisture in there, it really is about the moisture and ecology. Temperature even relates to moisture. If you look at the temperature regimes, they start off at the equator and they go all the way up to the North Pole and the South Pole. And so that's really what this is about. If you were to look at those temperature gradients, then you look at the moisture levels, and the moisture levels are by the world circulation patterns. You can actually then come out with what are called biomes. Biomes are the life forms that are the primary producers. So you take that energy from the sun and you produce something out of it that you can eat. That would be your plant forms, and this is the biomes. So there's wildlife biomes, but they're primarily plant biomes that are driven by these two things. The wildlife is driven by the plants, but these two things are driving those biomes. So where are we? So everybody that knows all about their mathematics here, we got 100 centimeters of annual precipitation. 40 inches, okay, thank you, back there. And so 40 inches of precipitation, 80 inches of precipitation, 120 inches of precipitation over there, and you got centigrade. Just do it, centigrade's easy to break down. 10 degrees centigrade is 50 degrees, thank you. So 50 degrees and add 18 for every 10. So here we are at 68, and here we are at 18 against 86. So that's the temperatures. What's the average temperature for Lake County? What's the average temperature for the state of California? 2 degrees hotter. We are not hotter than the average for the state of California. We're about 66 is the state. I think we're 2 less than that. It's either that or it's 68. Yeah, 68 for the state, 66 for us. So we're right in here somewhere. We're right at 38-inch precipitation, right in here. 38 inches. We're all in the United States along the same latitude area. What's the average inches of precipitation for the United States? We're 38. And the average for the United States is 38. So here we are, right here, and we're right there. And so now we're going to look for our biome. What we are is, what's it say?
I have no.
Okay, Woodland Savanna. I know what it is. I just can't read it that close. Woodland Savanna. So what you're going to see along here, around here, should be Woodland Savanna, except that we have higher elevations where we get a little more rain and a little lighter temperature. We can get some temperate deciduous forest, both. We can get conifer forest and deciduous forest, and we can also get a little bit of savanna because we can get a little higher temperatures. So we're right in there. And when you look around this county, that's exactly where we are. It pegs it. There's several of these, and they all peg us the same way. So I just picked the one that looked the best. If you look around the world, it also says that there are biomes everywhere from the same two applications. Where you have tropical rainforest, you get a lot of rain, but you also have high temperatures, there's tropical seasonal, all of those things. Here we are, Chaparral, and temperate rainforest. We're right all up in here, right about there. Here's your rainforests that are on the equator, and yeah, it all figures out. The rain does not come, by the way, from the Pacific for that. It comes from the Atlantic, sweeps in, because there's a big mountain range in a way. So if you look at the U.S. a little bit closer, you can see that there is a lot of chaparral more to the south, a lot of desert back here because of the rain shadow that we talked about last time. And because of the way the rains come down, we're going to get a lot of forest. And where are we? We are right there, where those two intersect. And we get all three, actually. So in any case, you can see how the weather shapes down. That's that big polar vortex that we talked about last time. Also is an example there. All of the grasslands, everything fits that particular biome map. One more thing that you have to add to that to understand the vegetation is the soils map. So here's the soils map. They apply it over to California, and that's going to make a change in the very vegetation that you can see. You see, it's the same biome, but the plants change, and it's because of the soils. We have a highly variable soil type here, and if you ever hear the lecture, somebody really knows how to tease all this out, it's fascinating, because you could just take a step over, and you got a different soil type, and you got a different plant regime. You can see it. I'm going to show you some pictures of it along this north shore. And the other thing is that if you were to take a legend where all of the different biomes occur in California, and then you see where we are, there's that little, there's us, there's this, so we're right in there. That's where all of these things intersect. We are an intersection of ecotypes and ecosystems, simply because the biomes all come together. with the different heights, the different shadowing, the shading of the moisture that comes through. And in fact, if you were to look out at the lake, I see Mike back there, so I'm going to make mention of this. One of the fire chiefs basically petitioned to get the winds that come through every night named, and they're called the Konocti winds now. So we are not the Delta breeze anymore because we're not a Delta. We are the Konocti winds because we have our own special system. A good way to go. So here we are. We're wrinkly like a prune. We got pimples of mountain volcanoes all over the place. We have a lake that has been there for a long time. That warm water lake that has fractures and fissures and all kinds of stuff, and a big fault block that's dropping down at the same rate as the sediment coming in. Here's the Great Valley sequence over here that we talked about, which is outside our county, but it's kind of neat. And so right along here, too close for me to see, but right along here is that big fissure line that basically is all volcanic. You can see it everywhere that you go. Indians used to sit up here and throw rocks at the birds that sat down here on top of that field, and you can still see the remnants. The guy that bought it showed me a bunch of stuff that they used to throw. Now let's talk about the basis of all life, and that is the sun's energy coming in. We have water that we know is going to be available. It's in its three forms. We do know that there's carbon dioxide because carbon and oxygen is locked up in the earth and excreted out through the volcanoes, and so we have a lot of carbon dioxide. At one time, there was not much oxygen in its elemental form of O2 at all in the earth. It was all produced by this photosynthesis. So the photosynthetic process produced the oxygen, and it produced glucose and all of the other oses. Cellulose is one of them that is important for you to know because all the trees are therefore made of sugar. Every tree you see is made of cellulose, which is sugar, and that's why they burn like they do, because they got all that energy to release and all that energy to give back. And so that's the basis of all of the life is called the primary producer. If it wasn't for the primary producer, then you wouldn't get anybody else here. So the primary producer, and this is kind of the rule of ecology, is that if you had a weight of 100 biomass of any primary producer, the biomass of the things that are eating it is 1/10. And the biomass of the things that are eating the grass is 1/10 of that. So it goes up by virtue of a loss of 1/10. And so here we're up here somewhere just above that, an 0.1, 1/10 of that. The nice thing about us is that we can basically not just eat these guys that are eating these guys, but we can also eat these guys. So we can actually make a living by eating all different trophic levels, whereas the folks that eat this, the critters that eat this, can only eat the primary producer. So these are the autotrophs. They are the ones that are in charge of producing their own energy. The heterotrophs are the ones that go after the autotrophs in order to get their energy, or they eat another heterotroph. So when you start looking at the way that all of these plants are laid out in California, it's according to these zones of temperature and humidity or moisture and soil. And so they're all laid out in California that way, and you start to see the different things that are here. Some are found other places at this same elevation, some are not. So tell me, which one is this? Which one is this? Manzanita?
Manzanita.
And which one is that?
This is also a California.
And that one?
That's sticky monkey flower.
Wait, somebody had it. Wait, somebody said it. Sticky monkey flower. I'm going to call our hill sticky monkey flower because it is friggin' everywhere over there.
And it's sticky.
Yeah, it is sticky too. And so here's one more thing I want to add. And so when you're looking at these primary producers, they go through a succession to get where they are. They don't start as a tree. And they don't even start as a bush. They don't even start as grass. They start as rock. So everything you see, everything you are, comes from the rock. That's our closest relative. Sorry. But everything we talk about is from the rock. And so you start with bare rock, and you start to get bacteria on it. Then you get a little advanced bacteria, a little like cyanobacteria, and pretty soon you get mosses, and then you get lichens, and it starts to break down the elements through acid, and next thing you know, you've got better soil. Thousands and thousands and thousands of years, the soil is great, and then finally you get the annual herb stage, and then finally the perennial stage, and that's building up the soil through all of these processes of decay and buildup, and then finally, depending on the soils, and finally it goes to the scrub stage, things that will live because of the deeper soils and the capture of the moisture. And so some areas only get to scrub stage because you don't have enough soil, you don't have enough moisture. And so it can stop anywhere depending on those things. If it has enough moisture, key point, we're talking about fire ecology now. If it has enough moisture, then you can get bigger things to grow. It can be different things. So you can get something here that outcompetes that and takes its moisture away, and you're going to see more of this there. It's about moisture, and it's about separating out according to the moisture that's available and the soils. And then if you were to look at the rest of the area around it, the particular area where the succession is going on, you see why it's going on the way it is. So here we have ecological succession that you can apply to Lake County without fail. It's happening in your backyard. In your backyard, as you look up the slopes, the soil changes according to the different depositional areas because of the volcanics, but where it is complete for the different plants, you can actually see the patches that have worked in, and where there's a soil depth that is deeper and the backside of the hill, like right in here where you get the stuff sliding down, captured back in there, the trees are starting to pick it up. And they're saying we can outcompete the brush, and that's where they're going in. And so everywhere you see those trees, they're finding that they're doing pretty well, better than the brush. The key thing to pick up from here is that if you were to look at the successional stage and you were to add a fire to that anywhere, it may bring it back a step. Keep adding a fire, it'll keep it bringing back a step. You add more fire and you burn up the ground, it'll really take it back. You can take it back to rock if you want. And so without fire, knocking it back with enough soil, anything that's at these higher stages that can outcompete something at a lower end, you're going to start seeing it, and that's what you're seeing now. You're seeing that the grapevine move in all over the side of the hill, and with the oaks, it's actually the oaks are not doing as well as the grapevine. Here is where the grapevine is filling in amongst the oaks. So these oaks have been here for thousands of years. There's been fires running through there. You keep the fires out, now you're going to see the grapevine. Guaranteed. Everywhere you look in California, it's this way because they've kept the fire out. The fire people ought to be getting the fire in. They ought to be in charge of fire, not in charge of keeping no fire. And so the philosophies are dead backwards, and what happens is this stuff burns not only hotter than the oaks, it'll kill the oaks because the grapevine is now in Lake County at the same height as the canopy of the oaks. You lost control. There's only one way you can go backwards, and there can be a plan to basically make Lake County fire safe again, but it's got to have all these different elements in it. We're going to talk about this on the last lecture of the series, but this is the successional stages that are going on. The brush is working against the grass. The oaks are part of the oak and savanna, and then the grapevine is moving in and finding a way to outcompete everybody. And down in here, you've got the other oak, which is valley oak. And the valley oaks are starting to disappear too because, well, they're disappearing for a lot of reasons. Everybody's saying climate change, but that's not it at all. It's actually it has to do with a series of moisture levels. There has to be a series of moisture levels such that the acorns get started and can grow high enough that they can compete against the grazers. And that happens every cyclic number of years, and it'll happen again, and they'll get started again if they don't get cut down. So let's look at the Sierra Foothill Blue Oak Savanna and Woodland. You can see how it runs along the foothills. And Lake County, you can see where it is. There's your marker. Right there. I don't have my Right there. Okay, and you can see you have a blue oak savanna woodland here because we're right for it. If you were to change that to just all oak woodland habitat, it overlaps us almost everywhere. So we have the coastal live oak, we got the blue oak. If it's an oak, we got the valley oak. If it's an oak, we've got it. Of the 32 or so species of oak, we got a bunch of them. I'd like to count them someday. I can't say exactly how many, but we got a bunch. Everywhere I look, I see different kinds of oak. So we got those. And if you were to put the mixed chaparral on the map, it also covers us. So if you're going to get a lot of fire through here, it's going to go back to either oak savanna or mixed chaparral. Mixed chaparral being at a lower trophic level than the lower level on the scheme biome. That's what I'm trying to say. A lower biome from the standpoint of moisture availability because we're losing moisture here, and because the groundwater drawdown, a lot of reasons. And so you've got mixed chaparral, you've got blue oak, you've got coast live oak, you've got all that stuff right here in Lake County. Only county that's got that kind of diversity. And so now the chaparral biome, just to show you which way it's going, is described very well. It's a temperate coastal biome dominated by dry evergreen shrubs which are adapted to survive brush fires. So you get brush fires, you're going to get more of that as well. If it goes up to a higher level of organization and you don't get the brush fires and the fire does not take out the forest, then you're going to have a different kind of adapted species. For instance, the Doug fir basically covered this entire area with pretty much the same moisture level, except it was dissipating. So as you dissipate down to a certain level and you get the fire, you lose the Doug fir. If it were just changing over to another moisture level, the Doug fir can still remain. You'll still have Doug fir. So once you have change inside of a changing environment, you're going to lose something along the way. One of the things that I saw over on the coast when they cut down the redwoods was that they weren't getting back what they had there before. And they were asking why. Well, it's because you changed your local environment. You changed the redwood at the time when the environment was changing. Now they won't come back. When they do start coming back, well, it'll be with a vengeance because everything's right. And it's mild, rainy winters, that's us. Dry, hot summers, that's us. Many animals, including deer, birds, rodents, snakes, and lizards, that's us. We are Lizard City. And this is a picture taken during the ranch fire and the river fire. Wow. I was on the top of the mountain with the chief and Jay, and over here the river fire behind me was raging, and behind me on the left was the ranch fire that had just moved through and was moving towards the north. So the smoke had kind of cleared out, and we were standing up there and looking at it, and I said, I got to get this picture because it is worth a million words. Here's another thing you can diagnose once you start to look at successional species and the availability of moisture. There's plenty of moisture, enough to grow all of that. And so if there were changes to this such that when there were drier periods, the plants were at an advanced stage and taking care of themselves in a drier period, nothing else will compete. If you burn them out too soon, you burn them too hot, and you get a drier period, they won't come back. So you need many small fires, keeping the brush in adjustment to its moisture level, and then you'll have a healthy forest. It's all about change being managed against change. Nature does it naturally. So here you have on the back sides of these slopes where moisture is more prevalent, you see that change going on. They're hanging on bigger trees. On the front side where you have the sunlight, you have different species there. That's why all of these pockets happen. Now you have all these niches. Nothing wrong with this. It's just that you better hope that you don't get a really hot sequence with a high wind because then you'll lose it all. And if you did a lot of small fires in here prior to that happening, everything would be adjusted to the moisture level, be in better shape. The big wind and the hot wind would come through and a fire, you would not get the hot fires. I guarantee you, it's just a lesson of ecology, and it's all been written up. I give you nothing that I'm inventing. All of this stuff is well vetted, and in 45 years I've been watching it and talking about it and going to meetings with people that know about it. And it just doesn't seem like very many people know enough about it. So the little fires are good. Even the little fires with the big flame lengths show that you're getting into something that probably shouldn't be there. And so more little fires at the right time of year without the big winds behind it, and then pretty soon it'll all start to normalize again. Native Americans had a way of burning that basically was, if you set fire and it doesn't burn very much, that was a good fire too. So just keep setting the fire until you get it right. Just keep setting the fire. Because if you keep doing that with a lot of small fires, and I'm going to show you why these fires stay small here in a minute, but when the big fire comes, it won't burn us up. It won't burn us out of house and home. You won't get the big flame lengths like that and the radiation, all the rest of it. And when we talk about fire on that last night, we're going to hit this heavy about radiation and fuel loading, what it really means and what it really means to a person that lives here. But that'll be our fire ecology night. And this basically is good fire ecology. This is the river fire. You can see on the back sides of the slopes, it comes back quicker. That's because it's fire adapted and moisture adapted. The moisture levels are right, the types of species in there are right, and so the front end is basically what would be otherwise be grass. And if you would run a fire through there as much as you can, and whenever it would burn it, it would not look like this, where it's kind of creeped over the hill, modifying this landscape. It would continue to look like this, and it wouldn't change, it wouldn't get the big fires. So there, your river fire is a huge lesson. Love it. There's our Arctostaphylos, which is your Manzanita, and those are the guys that come back. And I had that in there to say that if the fire is too hot because it's burnt with too much loading in the area, you can burn out the crowns. You burn the crowns, they won't come back. So that's why you want to keep running it through there to keep it down to its moisture level also. If you keep it down to its right moisture level so that if there's less moisture, it'll burn. If there's the right moisture, it won't burn. Then the crowns won't burn, it'll come back. This was too hot, that area, and what we saw was not as many sprouts coming up here and wondering why. All I do is look at the soil. It's all hydrophobic. It was so burned together that it would resist water. You pour water and just stand on the top. If you were to look at a grassland that you know was properly treated by fire, you would see that the oaks are not rounded. They're in fact burned up, the sides. These are all trimmed. When oaks are trimmed, you got a good fire ecology. In fact, the fire probably went up like this. There's probably a knoll here, because that guy's not as trimmed as much. And you can read it. Now, the reason that I have that picture is because of the animals that are on it. Is it that bad? Yeah, Thule elk. So I took a picture of Thule elk there. Any case, and that's on the east side, but looking towards, if you were to look that way, you'd look towards Sacramento. So here is an oak that is starting to get long in the tooth, and some of them are all the way down and swoping out. They're touching the ground. There hasn't been a fire through there enough. If you have enough fire, those oaks will look trimmed up. It's the way they should look. And the other thing about it is, if you were to do it right and the grass were to burn through, that's all you're going to get. The oaks lose their heat as they burn up the side. I've watched them do it. They lose the heat and the fire goes out. So they kind of look bad to get all black and everything, and this all drops off, but hey, what? It's still a live crown. Everything likes it. So it's good. That's just standard fire ecology.
Jim, can I ask a question? I thought that the grasslands with the oak trees on it meant that that land had been grazed a lot.
No. I'm going to show you.
Okay.
Well, it did and it didn't. So she asked whether the grassland meant that the ground had been grazed. I'm going to show you just how that worked here in a second. Good question. Too quick, though. When I give you a cue, that's too quick. Okay, so we have associations with all the plants, and one of the oddest associations are the little wasps that will sting the plant with a hormone that the plant recognizes to pitch out or to produce a gall. It starts a wild growth, and it grows around the eggs that the wasp lays. And I thought I was going to study that once, because that's going to be my calling. I'm going to study. I found out there were thousands of wasps and thousands of host plants. I said, I'm going to study something else. Anyway, there's a bunch of them. You see them all kinds. This is a little fuzzy one that occurs here, and here's even a more fuzzy one. There are so many. I got one on our trees that look like the little jacks that you used to play with a ball, pickup jacks, whatever, jack and balls, whatever it's called. There he is. There's one of them. And somewhere there's 6,000 other species. Look pretty close to it. It's kind of, and you ought to hear a talk about this because these people who talk about it just are in love with it. But there's one of them there. I captured one. And now, this is my cue to tell you that it's not overgrazed, it's grazed. But there wasn't enough grazing here for when they brought over the European cattle. And so they also brought over the European grasses. And so the grasses got started because they outcompeted the grasses that were here. And so that was a problem for us from the standpoint of fire ecology, because the grasses that were brought over are shallow root. They dry out earlier in the year than the grasses that were here naturally. If you were someone out, this is why the old thinking of just go burn it, like I was talking about, doesn't work anymore. Because you're burning these grasses rather than the ones that were here. Those are the bunch grasses. You can see how the bunch grass is widely separated. They had deeper roots, and so they stayed green longer in the year. And so when you did go out there and say, I'm going to burn something, the stuff that would burn would be later in the year and not as much of it because it's widely separated. Here is the Indian rice is what they call it because the natives used to harvest the rice, which is another type of grass that's down where it's wet. And this one is called deer grass because the deer used to like the deer grass. If that's the case, and that one's called deer grass, what's this one called? No, fox, that's a fox. Okay, it's a coyote. I don't care what it is, but we got to call it coyote grass. That's good. I think that's a fox.
It's a fox.
Yeah, okay. Now that's the other guy that actually enjoys the open grasslands as well. That's my favorite bird of all time. Huh? Who? No, that's a burrowing owl. The burrowing owl actually will dig out the burrows of the other animals, let's say it's ground squirrels, and go after the ground squirrels and make a meal of those. The ground squirrels have taken over the burrows of the gophers, which have taken over the burrows of the moles. So the moles are the ones that started the whole thing. And there's a community of this underground network that the lizards and the snakes and the mice and everybody depends on in a grassland, especially when you get a warm grassland. So if they're successful with all of the other critters that are helped raised by the grasses and the burrows, you just meet the family because they can really proliferate and they can keep all your rodents down. So when you mess with the grasslands, you're messing with a lot of rodents coming into your house because they're looking for places to get away because there's so many of them. They just reestablish themselves somewhere else. So these guys I love. There's still some in Lake County, not as many as there used to be. Here's your hero. His name is Scapanus latimanus, which basically means broad hand or big handshake. Can you imagine that? Look at that hand on that guy.
I've got one on my property.
You got one on your property? Yeah, the moles are great. They took over our hill, and then, what are you going to do with all these moles? I don't know, you can poison them. No, you can't poison them. Got to get owls. You got to get something else. Well, the ground squirrels moved in and bothered them so much that the moles are not there anymore, and the ground squirrels are. So now we got ground squirrels everywhere. So I put up boxes for the owls. I asked them to move in. Please, us. Here's what's been happening in some of the big, expansive grasslands. They get rooted up. And of course, they're in there, these Russian boars are in there rooting out all of these different holes, getting things out of there that otherwise you'd like to have. And so that's made a big change in these grasslands, are the Russian boar introductions. And they will eat everything. I found a picture of them eating a fawn. I thought everybody would say, oh no. Yeah, there you go. And then when you get down near where there's water, permanent water, there are species that, in fact, like their feet wet. On the right, we have sycamore. Good. And on the left, we have cottonwood. I should have put in a black willow. It's all along the edge is black willow, so they just love it. It's the only tree form that just loves to stand in the water. So when you look at the forest extent in pre-European times, it's no different today than it was in pre-European times. We still have everything pretty much in the same place. Naturally occurring there, still occurring there, except it's in worse shape. It's all still there. It's just in bad shape. So when we talk about it, you can get it back into shape. You just got to treat it differently. We treated too much forest. And in fact, so much forest was treated, that doesn't come across very well, is all of these are national forests that were taken away by the federal government. We have 21 of them, and 21 independent, and these are political units. So there was different associations of assemblymen that wanted a national forest in their area. And so that's how they got divided up. And so here we are, right there. That is Lake County. So we have a national forest in Lake County. It's half of the Mendocino. The bottom half burned up, the top half is still there. And the forests, of course, have the unique growing pattern that outcompeted with their neighbor. And so they're in the farthest successional stage. Things kept trying to move towards where something will outcompete. They outcompeted by height. So if you grow up above everything around you and shade it out, and you drop seeds in over thousands of years, pretty soon everything that growing at the same time is going to get to the same height and shade everything else out. It's a different kind of competition. It's for light. You can see that some things have adapted to that lower light form, form of light coming through, filtered light. And so they've adapted to the low light. If you were to cut down trees and to get light in on top of some of these, they don't do as well. And their brothers, or they'll drop their leaves and regrow their leaves so that they can take care of themselves with the higher light intensity. So anytime your plants in your house or somewhere drops their leaves because you change the location, it might be due to light. They basically have to be lined up with all of the chloroplasts such that the light will get in and they can still produce, but if too much light will kill them. So anyway, that's the forest situation. And these are second growth forests. These have been cut down and grown back. So properly done, you can get a lot of forest. In fact, improperly done, you can get too much forest. This is a lot of forest. This forest is pretty much the way it looked like before it burned down right up north. There was a lot of trees. Not everything burned up there, but there was a lot of stems per acre. And when you get a lot of stems per acre, that takes a lot of moisture. And in fact, you can have a tight forest canopy, but you better have a damped area. That's the only way you're going to have it this tight. When you get it really tight and it's not supported by a good moisture regime, all kinds of bad things can happen. And one of them is, of course, you can get fire through there, and these things are too close together. When the settlers came over from the east with their wagons and whatnot, they were able to drive them through the forest without any roads because the trees were so widely separated. Not anymore. And of course, the Native Americans burning all the time allowed for a lot of the brush to be cleared out. This is what happens when you get too many trees and the forest moisture regime changes. It's not global warming. It's global drying. So we've lost all that moisture from the peel back of the glaciers, which was 2 miles thick of ice that went off from solar radiation directly into the atmosphere. All of that took thousands of years for it to disappear. And so now all of a sudden, you're not getting the snow up there, you're not getting the moisture coming in to support the very tight tree growth that's up there. This is all second growth, this is all planted forest. It's either that or seed forest. Seed tree forest is where they cut down everything but some seed trees and then the seeds come in and repopulate it itself. But it comes in very thick because the sunlight can hit all of the ground. So these forests are out of kilter with their moisture level. And now what they will tell you is it's climate change. Well, that's true, right? And not as much moisture. And it's the bug. Bark beetle, thank you. It's bark beetle. There's your bark beetle. Now your bark beetle is there anyway. The bark beetle bores its hole in, gets underneath the bark, and then goes along and eat cambial layer. Unfortunately, it turns blue here because there's a fungus it's called blue stain. It's a fungus that actually will grow into all the pores and clog them up, and so the moisture and the food exchange can't happen anymore. So over the years, the forest has adapted to bark beetles by what's called pitch out. If there's enough moisture for the trees and they're healthy with that moisture, they produce enough glucose, sucrose, all those things, forming pitch. And so these guys get started and they will get pitched out. They'll get caught up in the pitch. You know the little stone that women like with the mosquitoes in it? What's they called? Opal? Amber? Amber? That's amber. That's going to form amber in 1,000,000 years. So there's your amber, and there's your next star of somebody's necklace right there. Just saying, you know, looking ahead. But pitch out is what you don't have anymore in the Sierra Nevada. And so that's why you got these big festations. Here's the forest for the ecologists. Man, I worked on this a lot when I was working on these things. What you want is widely separated big trees, older trees, younger trees, lots of separation between everything, and lots of things falling down, keeping that separation. So you get a big tree, and when it falls, ain't nothing going to grow there for a while until that tree will dissolve into the earth. And so you have all that decomposition going on, which really helps. Big trees allow you to grow smaller trees, and then the bigger trees that are around get more light, and they'll grow even taller until they fall down. That's the forest for the ecologists. It's not the forest that foresters want to see. They want to see them all grow up, just like the ones I showed you earlier, at the same level at the same time. So when they harvest them, they put them on the trucks. They're all the same uniform size. And the biological community that we're missing in Lake County and in the forest, now that it's all been burned, is this one, the rotting log community. There are more species associated with the rotting log community in the forest than there is forest. It's amazing. I went trekking out with some people who are doing some theses on this and helped them do their work. We tore these logs apart. Wow. You just sat there for days counting everything that was there that actually will work off of a rotting log. Now, one of the things you have to do when you're an ecologist is you have to see what caused something. So you can kind of figure out, is this natural? Is this a disease? What is this? As it turns out, I don't see any rotting logs. I don't see a stream anywhere. These trees have pretty skinny branches and leaves. This actually is in an area where the wind can come through and blew down everything that was there. I thought at first it was a big flood, but it's a big blowdown area according to the story. And then as they try to grow mass coming up, and were able to withstand the wind, then they started to straighten out. This actually occurred all along here in this mountain, and that was all from wind. On this one, is a little different. That's called pistol budding. You don't want to build your house near here, and the reason is the entire slope is moving, and the tree is trying to compensate for that slope movement. So that's kind of a standard pistol butt situation. And this one here, I know the story of this one because I saw it. There was heavy brush growth all the way around, such that this little oak, blue oak, got started in the center of that brush grove, old Manzanita, and was trying to find a way to get out to where the light would hit it and it could grow up. It went all the way out here, and it was actually green at one time. And then when it was released out one side, the tree said, I don't need that anymore because I have this out competing and producing more food. And it cut everything off to this, and that died. This died because the same reason. Everything underneath did not grow simply because it didn't get enough light. And then it got started and took off. So once the brush was cut down, that thing took off. And it's still there today and thriving. It is 8:06. Would you like a 5-minute break? Yes. All right, 5-minute break.
I can give you all oodles of history. The car is now on display.
Trees that grow laterally do not grow laterally because they lose branches somewhere else to balance them. I heard a talk like that. I almost fell out of my chair. No, the tree actually grows laterally by virtue of laying down two types of wood. One of them is a tension wood on the upper side that holds it up, a stronger wood, and another one that grows on the bottom side that holds it up from the bottom, a stronger wood. But the structure of them are different, and you can look at it underneath the microscope and tell which one it is. It's sclerenchyma tissue if anybody wants to look it up. But in any case, compression wood and tension wood, that's why trees grow laterally. You can laugh anytime you hear about someone that says, oh, the tree has to balance out by losing limbs out here or whatever. No, it doesn't happen that way. Okay, there were billionaires in millionaire terms back in the day. So when they were millionaires back there, they were billionaires today by virtue of the difference in economy. But this was a house built out of the old growth forest, and this was built in the center of the old growth forest log processing plant. And so he, as Carson, and so he is Eureka. So he basically built it in the center of the plant, and he could walk around the fenced area up there and make sure that everybody was at their job. And so in order for everybody to think that he was there watching them, he hired a guy to dress like him and walk up there daily. And then he had a little tunnel where he could escape and get out. And anyway, that's a long story. I had dinner there with the people that own the house a couple of times. It's amazing, 126 woods from around the world. The place is just phenomenal. He had billions of dollars. So here's how he made his money. It's on the big trees. All the loggers here are dressed pretty well, so things must have been pretty good in the forest, right? Well, what happened once a week, you got to give these guys a break. It's hard work, and they got to feel like they've got to take a day of rest, so they bring in a preacher, and they make everybody dress up, feed them a good meal, greatest job in the world. And every once in a while, the investors back east would send out a photographer to only show up in camp on Sunday. And if you show up in camp on Sunday, this is in about the time of the Civil War, they would take the picture of everybody dressed up, and they all wanted a picture taken. And of course, the bosses would tell them, yeah, they said to take a picture. They would send them out, and they would put their arms around a tree to show how big it was. They would sit on top of the tree and all that sort of thing. And so when the photographer came back with these pictures, they would show all these happy, well-dressed people in California and all of these great trees that they dropped. Invest more money in our company. Look how well we're doing. Everybody's happy. So that's the story of that tree. And by the way, how many women are in this photo? Two. Yeah, they're the cooks. So the trees were moved in a lot of ways, and the way the trees were moved caused a lot of the damage. They had to move them such that they couldn't go up the hill, right? The trees were in the way. They couldn't go around the hill. The trees were in the way. And oh, by the way, when you cut a tree, it's easier to drop it and pull it down the hill. So they just went up the streams. And so when they went up the streams, they laid a lot of track right in the stream bed. And a lot of the roads to haul things out were in the stream bed. And there were more tracks laid in California than all of the United States combined at the time this photo was taken. Maybe a little earlier, because these are, it's probably about the same time. But there was a lot of track laid in California up these streams. And that was my job in the forest ecology side, was all this stream restoration stuff that we're doing. And you can see just how many, it took a long time with two axes, double-bitted axe, to take that thing out. And by the way, if you don't know how to drop a tree, you cut the bird's beak on the front such that with a gunning, which two pieces of wood, which is called a gun, sighting gun, you would stand out here, about 20 feet out, these things are long, and you would aim that gun. If it's just right here and just right here, it's right where it's going to fall. And right there is where you lay a bed. And you get a whole bunch of people out there and carve out that bed and bring the dirt in so that when the tree falls, it won't hit something and break. These are too valuable for that, so they got to drop flat on that bed. And you can hear it. They gave me a saw. I worked with some guys who are going to drop them anyway. And it was the forest that they filmed one of the Star Trek things in. The one where they flew down between them. What was that called? Yeah, so they were cutting those trees. I said, oh man, look, well, the boss not watching. You want to cut a tree? I said, oh yeah, you got to cut it anyway. So they got on this great big saw. I couldn't hold the damn thing up. So they had to help me hold it up and got a chance to cut that tree down. But in any case, it fell down in a bed. So all of this is what tore up the forest, changed the ecology, and so everything has changed in those forests, and now it has to normalize, has to go back, and it isn't, because it is, of course, mismanaged. You get a lot of fire through there. And of course, it goes on and on with the story. I got to show some of these because I found a lot of these out in the forest. These are steam donkeys. It's on big skids cut from huge logs. And it would pull itself along through the stream bed. And then when it got to a point where it's going to pull logs down, they would tie it off on a big tree, and then you take the cable up and you could pull the log down the hill. And of course, you pull the log down the hill, you just make a big rain trench and all the dirt comes down. They'd pull it down to where they could build a big dam, and they would float the logs behind the dam. And this happened up until the 40s and 50s. They were building these big dams. The logs were floated behind them. Then they would blow a couple of supports out of the dam, and it would fall down and float the logs down the stream, called a splash dam. And that really helped those streams a lot, right? Well, this particular one is a floater dam with a hinge gate, and then they would put the gate back up. So what happened was the big splash dam with the logs went down, but they all get hung up, and you need more water. So they would rebuild the dam, and then they'd keep splashing it, and it goes down as a slug, float the logs, and move them a little bit further down the stream. You ought to see the damage from that. So here's the original Skid Row. These are 6-person houses, and they're all linked together, and the steam donkey would be at the other end and would pull them up, and then the next row and the next row, and it would pull them up to where they have the next camp. And that way, you don't have to rebuild the camp. And of course, you took them along the stream, right? And you got the post office, you got the chow house, you've got a skiddable water tank, you got the skiddable outhouse, right? So everything is there and it's skiddable and it moves around. This is the original Skid Row. That's where the name came from. This is what the forest looks like in some areas. I saw a lot of this. This is slash left over from behind. And if it's a wet forest, it isn't going to burn. It's going to just sit there, right? And if it gets consolidated with soil and it gets pushed up into a bank behind the stream, then of course salmon can't get up and it's a mess. There's a stream right here. Good planning. So we did a lot of restoration work trying to get the salmon going back up the stream. Of course, when you lose your seed population, it takes a long time to get them started again. And the salmon breeding and dying in the streams basically recharge the stream with nutrients for the young. And so if you don't have enough salmon to recharge the stream, of course, everything's got to adjust. You get fewer survivals. At the same time, they don't grow big enough because, I say there wasn't enough nutrients. They don't get big enough to go out in the ocean and survive. And oh, by the way, the ocean would necessarily change from hot to cold to hot to cold. Well, we're in a warming period with a big warm blob out there. And so the ocean conditions have changed such that you're losing your salmon as a result. And that's why there's a lot of consternation about those populations. Took a long time to figure that one out. I was involved in the spotted owl stuff for a long time. And this is what slowed down a lot of that. So new rules came in. I taught all the foresters how to hoot for an owl so that they would go out. They said, well, how do you know there isn't any owls out here? Okay, I'm going to teach you how to hoot for an owl. And every time that you find an owl, you tell us, we'll go out and we'll certify that that is a real owl territory. It's actually a spotted owl. So they not only figured out how to hoot them in, but they would bait them in. There's the mouse right there. It's white mouse, not normally found in the woods. And so this is one that came in and got his mouse because they called him in. So how many people here can hoot like a spotted owl?
Are you going to demonstrate? Yeah, sure.
Okay, all right. You weren't going to beg for it. I wasn't going to do it. All right. I taught the grade school kids how to do this too. You ought to heard them. Woo! 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 I bet you I'd get an owl out of the forest with that. If you don't do the die off at the end, you got the alert, I'm big. And then, this is who I am, and then I've run out of air. And that's a spotted owl hoot. And we could get them in almost every time. And what they do, the males would come in territorially to defend their territory. Would never get a female. And so that's how we knew how many males we had. And we found all kinds of interesting things out about the owls. And by the way, the foresters were right. Okay, back to the primary producer. So it also happens for trees. But I wanted to mention that the soil decomposers are extremely important. And of course, the primary consumer is extremely important. And those that eat the primary consumer are extremely important. And you get this web of life buildup. One thing dependent on the other. Everything depends on the next thing. It all starts with the sun. It's all producing oxygen. And it all needs carbon dioxide. Do not be afraid of carbon dioxide. The levels are perfect for good production. In fact, the carbon dioxide is one of the necessary things, along with a lot of other nutrients, and the sun, chloroplast, photosynthesis, very complex carbohydrate. All of that goes into that's your sugars and stuff. And then when it's eaten, the mitochondria produce carbon dioxide again, takes in more oxygen to make all of this happen, and then releases water back into the earth. So all of us are part of that cycle, but we need the primary producer to break it into the sugar so that we can break it back down again. So you got the primary photosynthesis, then you got the aerobic respiration. The only percentage of things that don't belong in this would be the anaerobic critters that don't need that aerobic respiration. If you were to look back through billions of years, when you didn't have the free oxygen in the atmosphere, and you had a lot of carbon dioxide and sulfur dioxide and things like that, then the prokaryotes were the ones that basically formed life, and these were the cells without nuclei, are the prokaryotes. These are your cyanobacteria. So cyanobacteria will flourish wherever there is a reducing environment. Clearly. Look for that scenario, you're going to find cyanobacteria just take off. Except that they've improved their model a little bit billions of years later. But we will talk about that when we do the Clear Lake talk, and that will explain how all this is happening and then how we can fix the lake, I hope. I'm not so sure we ever will because nobody can get together. But once you get so much oxygen into the atmosphere, and oxygen is more reactive, the eukaryotes took over. These are the cells with nuclei. These cells are more robust, they outcompete, and oxygen in the atmosphere is toxic to the prokaryotes. So you get too much oxygen, they don't do as well. So if you want to get rid of prokaryotes, you add oxygen. So if you have a lot of oxygen, you have a lot of reaction, you got something that'll really sustain a lot of life. Now things start to get a little more complex. And complexity builds on top of complexity until you have the Cambrian explosion, where life just absolutely takes off because life figured out DNA and the rest of it. So once the DNA was figured out and how to actually morph and change and do the best job of understanding how to use oxygen, all of a sudden you started getting everything else that is in association with oxygen. So when they look for life on other planets, what do they look for? They look for liquid water. They look for a planet that's big enough to hold a magnetic field around it. They look for one that would have oxygen. Now this is the web of life, so here's all the primary producers down here. Here's the people that eat the primary producers. Here's the things up here that eat the things that eat the things. And here's the ones that eat the ones that eat the ones that eat the ones. And we're up here where we can eat all of the different things. That makes us a generalist, and that's one of the reasons that we have figured out how to change stuff down here and cook it and make it work for us. We've learned how to change or recognize things not to eat here and make it work for us. Same thing here. I know everybody likes praying mantis. It's one of the delicacies in some countries. Not maybe for me, but the elf owl, loves them. Western diamondback rattlesnake is excellent. So we've learned how to go between all of these tropic levels. Of all of the things that have been produced, there is an abundance of species that are in the insect category. They have really, really done well because they're able to fit each one of the niches and get away from things that are too hard for them, things that are chasing them. So the insects have done really well, and they've outproduced by virtue of what's called R selection. R selection is you produce so many that they can't get them all. Case selection is where you kind of figure out a strategy to survive. And I'll show you case selection here pretty soon. But you can see that there's a lot of insects. And in fact, I looked for a lot of models. This is probably the one that tells you the best cut. But it's a little wrong from the standpoint of proportions, but there's a lot of insects out there. And insects have learned how to manipulate insects. This is a case of mutualism, so that each benefits. Here's the ants hurting the aphids. The aphids pull the juices out of the plant, and they extrude a honey juice out the back. And to the ants, it's honey, right? So that's basically what's going on here. And the aphids are getting pushed around to different leaves. And when the ants think a leaf is not producing enough, they will move aphids off of it. They've figured out too many aphids is not a good thing, so they'll move them around. And they get these honeydew, that's what it's called. They get the honeydew off of the aphids, and that's the food for them. Now, where's the mutualism? They get moved to a leaf that works, and they get protection from predators. So your ladybugs that you put in the yard, the ants are going to try to keep them out. And in fact, ants are very, very good at mobbing these predators of their aphids. So that's mutualism. Now here's one is predator-prey. And so everything adapts to everything that's out there, and the insects have gotten themselves a mammal that figured out the birds must be onto something. I'm going to do that too. And so it's our only flying mammal are the bats. And in Lake County, we have 3 that I know of. If someone knows of others, let us know. Here's the brown bat. It's our biggest one that you see at night. That's how big it is. Here's the little brown bat, and you can see by virtue of the person's hand, they're very small. And then this one here, you can see the tail is free. That one, the tail is enclosed by the web. He has a tail, but the web comes down. So that is a Mexican free-tail bat, called a Mexican free-tail bat because it siestas or it winters down in Mexico. So it takes a vacation in Mexico, then it comes back up. I know we have them here because I found a couple in my grill the other day. Yeah, I know, little guys. Well, I know, thump, thump, you know. I said, oh, what was that? And they do try to get out. They only fly. They overheat. Did I say they were mammals, right? And so they're holding a lot of stuff up, and it takes a lot of energy because they're mammals. And so they try to stay out of the direct sun during the daytime. And so they will fly at night. If it gets too dark, the insects aren't out, so they're not going to fly during the day. So they're called a crepuscular animal, and they will fly in the morning and they'll fly in the evening, right at those day break and the drop. That's their crepuscular time. And these guys are hanging out underneath someone's porch. And it's just a cool spot. They're all kind of hanging together. Some animals will separate out into their niche by letting everybody else know this is my territory or I'm not part of your territory. So that's called cryptic coloration. They blend in with the darkness, and they mostly move at night. They blend in with the darkness, but during the day, if anybody sees them, they're saying, you don't want me. And that's basically what that means. Now, 95 to 98% of the skunks will look like this, and the rest will look like this. That's not too many. I've only seen one in Lake County. That's a spotted skunk, and they are around. Here's your friends. This is sitting on a porch. No, I'm not kidding. So the mountain lion has the big tail. When you see something run that looks like a cat, look for the tail. First thing you look for, because that guy hasn't got much of a tail. He's tail challenged. Not too smart either. I was sitting out at night waiting for everything to quiet down, and I was surveying a pool, a pond, and I was going to do eye shine survey for a permit that I was going to get, and for this company. So I took my light and I shined out to shine it to see red-legged frogs. And red-legged frogs, you can tell from the eye shine and a lot of different things, you can tell what they are. And so then you document all of this according to the protocol. And I was just getting ready to turn on my light, and this animal come walking up. I says, what the hell is this? And he comes walking by, and it's bobcat. Just walk. I say, if I turn on this light or honk the horn or yell or shoot my gun or something, I swear he would have died on the spot. Had no clue I was standing there. So they're not all that smart at night. I don't know, maybe he's just old. Now here's the other critters that happen here in Lake County. Yes, we have porcupine. I was out in a search rescue one night, and it was real dark, and I was, search at night for tracks is really easy, and because you can control the light. But anyway, I was standing there waiting for someone to catch up with me because I had a partner and they were going to turn around. I think I was going to do it alone, but I was waiting for him, and I thought my radio had squawked. It's not the radio. What the hell? It's up here. And it was a porcupine that was asleep in the branch right above me, and he was snoring. A horrible snore. So right here is a black bear, and the black bear, which one was named first? The cinnamon phase of the black bear or the black phase of the black bear? Yeah, the black phase. If they had named the cinnamon phase of the black bear, we would have had cinnamon bears. But no, it's black bears instead. But in any case, we get them both phases here. They just go through a different phase at different times of the year. Usually in the winter they're black, but sometimes it'll go into the summer, depending on their habitat and what kind of diet they have and where they're holed up during the winter. So we have our coyotes, and if you wonder what's wrong with your dog, all the dogs are alike. They do a lot of howling. And this one, of course, is letting everybody know I found dinner, and the folks that are interested in that are looking out right there. Now let's see, I can't remember if it's the next slide or not, but you can see, if it isn't, it'll be the next one after this next slide. But I didn't want to spoil this because I'm going to show you the only picture that I know of a critter that has only been seen by a few people. It's the Lake County Sasquatch, Yeti, Bigfoot. It's our Sasquatch Yeti Bigfoot of Lake County. It isn't. What it is the dog family has basically been very, very successful. And so the next one will show you the Yeti, and there he is.
It's just a brown bear walking on his legs.
What is the most successful animal to walk on their hind legs and look like a human? That's not a human.
Brown bear.
It's the black bear. Or a grizzly, or just about any bear. They have a very, very well-articulated hind foot. This one has an injured front foot, happened when they were young, and he walks around just like a human on his back foot and can outrun you on his back feet. Look it up on YouTube, because now people with phones are starting to see this more often, and they record it and they put it on YouTube, and it kind of breaks the myth. I'm really sad to hear that, because I've known about this for years, and I've actually seen one in Lake County. It was again search and rescue, and we went into a guy's farm area, and he had fruit trees, and he said, and man, you guys, he's also growing some other things there, but let's call them fruit trees. So he says, man, have you seen the bear? And I said, what do you mean the bear? He said, well, he comes up, he stands on his hind feet, he grabs the fruit, and now he's got arms full of fruit, and he walks over to the next tree and gets more fruit, and he walks out, and then he drops it in front of the cubs. Oh, give me a break. I saw it, and this bear walked out with, I could see him from the back, and I says, nah, it's somebody wearing a black coat. Until I saw it myself. So there you have it. Black bears, the people who have known about this forever, and this is why I don't know why everybody doesn't know about it, the circus performers knew about it. They would train bears to walk around in suits and all kinds of stuff, and everybody thought, well, they're just trained bears. They actually don't walk on their hind legs. Anytime you get an injured front paw on a young black bear, one of the things that will happen is that they'll start walking on their back legs if in fact they get the signal to do that. In China, there is a park where the visitors come in buses, And in order to encourage the visitors to throw things to the bears to feed them, the bears will stand up and start walking around. And I've seen pictures of this. So it's all on YouTube, you can find it. One of the things that things need, of course, I talked about the tule elk needing grasslands that are wet, that sort of thing. That's the way it used to be in California, and then it stopped being that way, and they had a rancher kept all his tule elk to himself and not let anybody hunt on his ranch. And then finally they were moved up to, Valley. I've just lost it, where Southern California Edison took all the water. Owens Valley, thank you. I knew someone to help me out there. Owens Valley, the tule elk up there were outgrowing their habitat, and Fish and Game wanted to move them. They said, you're not going to get a budget to move them because there's no money for us in moving these things around. And we don't have the budget. So they leaked information out, Sierra Club members. They leaked information out to the Sierra Club. The Sierra Club sued the state of California because they had not taken care of an endangered tule elk habitat. Therefore, you got to move the tule elk. And the money all of a sudden came, and we moved the tule elk, and they're all over the state now. You can thank these herds from that lawsuit from the Sierra Club. But that's what it takes sometime to get people's interest back into protecting the species that are so important to California. So there's your tule elk that's up at Lake Pillsbury in California. It's one of 2 herds, and these herds are pretty big now, pretty good size. Here's the other critters that use the holes that I talked about. And some of you have seen, some of you haven't. Garter snake, gopher snake, rattlesnake, and
Yeah, what is the little snake?
they're all over the place. I didn't know it until we were building the house and I was digging around. They were in rotten logs a lot. That's how I noticed these snakes. I knew them. It's a ringneck snake, little teeny ringneck snake. And they are in the duff and in the holes and whatnot of Lake County. And here is the
Red.
sharp-tail snake. And the sharp-tailed snake is everywhere as well. And you can see how small they are. These are teeny snakes. And so we got teeny guys. They love the rotten logs. If you don't have enough duff and stuff around, they don't do as well, but we have a lot of them on our property. Now, everything that you've heard about the king snake is true. Yeah, they'll eat rattlesnakes. And one thing about eating rattlesnakes and lizards is that all of the scales go backwards on these critters. So once you get started at that end, they can only go forward. So it really kind of helps them out. You don't have to move much. Let them do the work, you know. You kind of walk along with it. I watched it. There it is. And then you got the amphibians and reptiles. These are all amphibians and reptiles. So this is the one you don't want here. These are the ones, the red-eared slider, it comes up from Florida. They're that big, and they're in the circuses and the fairs, and the kids buy them. They sell them to the kids, and then they put them in the aquarium. And if they survive the aquarium and they say, you can't keep that anymore, you're not feeding it, okay, put it in a lake. If you want to see red-eared sliders take over, go to Shasta Lake, and you'll see them everywhere. This is a guy we've got still. I don't think that one does well in our lake. That's one reason I'm not so big about changing things, because I think we're keeping some things that are bad out. And this guy is the western pond turtle, and there's only one turtle that is native to California. That guy's a toad, and all of these are parotid glands. They're poisonous to critters that eat them. So here's how critters know not to eat them. That's like the skunk. There's a white stripe right down his back, lets everybody know. And he does very well on the sunny side of the hills and slopes around here. Does even better on the backside. But we're on the sunny side, and we get the toad all the time. I had one that resided here quite a bit until I walked out at night, and yeah, barefooted. But we saw one since then. Yeah, okay, I shouldn't have told that story, okay. Red-legged frogs, we don't have any in the lake. The bullfrogs have pushed them out a little bit. But if you do see one over there, let me know. This long parotid gland down the side is the way to tell them. And then, of course, the obvious legs. But this guy here is the one that you hear at night. It's the tree frog, Hyloregula, but we call it also the western chorus frog because they all sing in chorus. beep, 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 and everybody's doing it at the same time. And it's really fun to watch a classroom of kids, when I give a talk, try to do the chorus thing. You know, everybody peep in unison. Yeah, it's funny. So here we have other critters that are in the forest that are important to it and to us. These guys are in dry habitats as well. This guy's Tarica turosa. That's the California newt, and sometimes when it rains and they get enough moisture, they can come out onto the forest surface. You'll see them around. They'll migrate. And then this is granulosa, which Tarica granulosa, which is a granulated newt. It's the same newt, except that they were separated by space from glaciers in the Klamath. And so on one side of the glaciers were the granulosa Taricas that turned into the granulosa, and on the other side were the Taricas that turned into the turosa. And then there was one more that has a red belly, Tarica rivularis. And so they were actually teased out this change by a biologist that said these are all the same one, they're just morphed out differently, and so now they're slightly genetically different. And they have little different habitats. That's called genetic drift. If you were to separate populations, they will change genetically. And humans have done the same thing. If you wonder why you have different races in the north and the south, the east and the west, it's all genetic drift. And they're all kept apart from the fact that they haven't interacted enough to change that drift. And so the Native Americans that came here were here for quite a while by themselves. And so the interchange between other genetics was very low. And it's the same with the Chinese and the Japanese and so forth. So this guy here is an important guy in the forest. It's called Batrachoceps attenuatus. And that basically translates to short legs. And he's really challenged. That's again our foothill yellow-legged frog. This is a forest species, Anides, and so he likes to be around anything that's wet and underneath the trees and whatnot of a wet area. So you see him here in such a dry county, but he's all around. And then that guy there is where the streams run all year long. That's your giant salamander, and they will get a foot long. Unless you're in Japan where they get 3 feet long. And mostly body, not tail in Japan. Here it's mostly tail. And so that's your giant salamander. Now, I want to throw one out there to show you the dimorphic differences in size between the male and the female. You can pick out which one is which. And then the product of that, which is these egg masses right here. We know this is in clear water because of the fish down here. These are the 3-spine unarmored stickleback, which occurs in Lake County in warm water. And then up here, I have some alligator lizards that are showing their the way that they mate. So this actually is called amplexus. And so what he does is squeeze in a certain way, and she gets the message to ovulate, and then there's sperm to come out the back of the male at the right time, and then that fertilizes the eggs. And if there's too much current, then they don't get fertilized properly, and you can really tell the difference. But these guys are what we call eyed up. Biologists would look at that and say, oh yeah, they all got eyes. And that's a very successful egg mass that's going to produce a lot of yellow-legged, foothill yellow-legged frogs. I want to show you one life history cycle so you can see that you got to be careful about what you think. Here's a toad, and it goes through a very extensive life history. One of the things that people who would try to make change in the landscape would tell you is that, okay, we'll move all the toads out of the way, and then we'll fill in the pond, and they'll all be safe. Except for the life history cycle. They got to have, the critters in the water. And we got that a lot. And you'd have to go through all this explanation and whatnot, and then you get a lawyer in your front door. But life history cycle is extremely important to learn how animals associate with their niche and what they have to have for their habitat. You can go anywhere and you can learn what the animals are, and that's a good thing. But there's a story behind the story behind the story. And there's a tropic level, and there's species that depend on species, and that's even a better story. So everything can be determined as from these charts. I love this particular butterfly. I only put one up there because that's the California sister. California sister. And so when you get 2 or 3 of these together, you got 3 sisters that dressed alike. That's the story. That's how it got its name, by the way. Bad? No, it's true. That's how it got its name. That's the California sister. It's got its common name was from the fact it looked like sisters that dressed alike, and that stuck with everybody. So that's why, let's call it this common name. So here's one of the predators that's your friend. The dragonfly is taking out a wasp. Dragonflies used to be even more common than they are today, but you have less swamp area, less open water areas, and hopefully we'll restore a lot of that back. We get dragonflies back. Predator-prey relationship. This is a parasite relationship. This is American mistletoe. American mistletoe. And it basically is a fruiting plant. It takes its nutrients from its host. The host doesn't like that because it gets into all of the phloem and phylum of the host plant and will plug them up, and then a branch will get weak and fall off, and that sort of thing. Usually when the host plant is weakened, then the parasites really get a toehold, but they have berries. And the association with the berries and its propagation is the birds will eat the berries, but they can't digest the seed. So when it is digested and pooped out, it sticks on to another branch, because birds, every time they get ready to fly, they lighten the load. And they'll leave something behind. And so there you have the way that it all gets dispersed. Everything has a story, so that's your American mistletoe. Here's some more stuff. This is parasites, parasitic plants on top of plants. That one is the dwarf mistletoe on pine. So just look for the little needles. Pine have little needles, narrow needles. That's the dwarf mistletoe. We got a lot of it in our pines where they are drought stressed. And then, boy, I'll tell you, the things start falling apart in the forest when that happens. This one is...
Spanish moss?
Huh?
Spanish moss?
No, not Spanish moss. Nope, not lichen. It's parasite. It's a plant that's a parasite, and it's called dodder. Dodder actually will just grow rampant over some plants. We have it here in a form that's called broom rape because it is in the shape of it kind of it sweeps with the wind, and it's orange, and it looks like a broom laying down, but it's actually a parasitic plant. I was out, the reason I included this was that I was out onto the Anderson Ranch, and they have it out there. So in any case, it is a flowering plant, and I gotta move this forward. We have a lot of critters in the lake, and so that's a witness of it. And the fishermen will tell you it was like that day. You know, we're just hauling them in, except for these guys right here. You notice that they're not paying too much attention. They got skunked. And so this is what Clear Lake really looks like in the fishing season. Those are Asian carp. We don't want those around. And then, of course, fish get bigger. Any fish that's here can actually get bigger somewhere else. So what they tell you is not true. They don't grow the biggest here. And in fact, there's some places you can get catfish that will... I want to get one of these catfish from the Amazon and bring it up here and have it caught to be the record catfish, and then stand back and buy hotel stock because... And if, in fact, it gets real big. Now, the fishermen also have a motto. It's life is too short to fish without beer. That's a bumper hitch thing. And then, of course, I want to say Lake Pillsbury is the headwaters for the eel. That's in Lake County. It's all the headwaters for the Russian River as well. I won't say too much about that, a time problem. And so we think that it being a big dam builder, and dams are bad, not necessarily, because we don't have the snowpack anymore. If you want fish and the eel, you're going to have a headwaters lake, even if it's a dam. Anyway, life cycle of the fish, if you learn it all, you can figure out why all this is important. That's what I did for a living for a while. And one thing about Cache Creek is that it's the only exit, that's Cache Creek, the only exit out of the Clear Lake. And of course, all of the various streams that come into Clear Lake, there's 11 major streams. Those are where fish will go up to spawn. We do have a spawner, that's the native hitch. They're anatomous. Anatomous means uprunning. They run up the stream to spawn. We have another one, sucker, but that's the one everybody's concerned about. It's listed. What does it mean when a fish goes downstream to spawn? What's the word for it if anatomous is going upstream? Catadromous. How many catadromous fish do we have? Name one. Eel. What's another one? Sturgeon. Oh, anyway, I got carried away. So they will get up there over the gravel. The female's downstream, the male gets upstream. There's a lot of action with everybody trying to help. Everybody tries to help. And then she gets all excited. She extrudes eggs. They extrude milk. The water washes one over the other. It's a demersal egg. It will get heavy and fall down and stick in amongst the interstitial space of the gravel. That's why it doesn't go all the way downstream. Whereas for your salmon, of course, they kick up the gravel, lay the eggs, and kick the gravel back over it to hold it down. These guys are not quite as sophisticated as the salmon, just saying. And so we have in the lake, we have a food web, just like we do on land, very complex. This is a simplified version, but I think you can simplify it even more. It's big things that eat small things, that eat the primary things, that eat the things that actually use the sunlight. And that's really what food webs are all about. But you do have to know something about zones. And I'm going to run out of time, but there's one thing I want to get to. And the zones are the literal zone here, where things can reach the light, and the limnetic zone here, where the light has to pass through the water, and the primary production still grows in there. And then the terrestrial plants are up here. All of this is your transition zone. And then the benthic zone down here is a lot of things take place, which I won't get into, but I'll tell you what, it is very complex and a lot of fun. That's why I spent so many years at it. And this is Lake County's littoral zone right here with all of the tules growing up. There's not nearly as many tules as there used to be. We have a 85%. I'll give it 85% reduction. I think it's closer to 9, but we don't have nearly as many, and you'd have much more life form and much more stability in the lake life forms if you had more tules. And so right in between any kind of ecosystem like the aquatic ecosystem and the land ecosystem is you have an ecotone. One reason you have so many species in Lake County is because there are so many ecotones. There are so many ecosystems that are side by side, and both species can occur in the center species, or center zone. So ecotones is where everything occurs. One day I saw a Harris hawk fly by, and 5 minutes later I saw a sharpshin. They don't occur together anywhere but Lake County. Absolutely amazing. So here you have it kind of laid out. The habitat specialists of the forest species, the habitat specialists for the open land species, wherever there's a habitat gradient, which we have lots of it, then you're going to have both species occur. The habitat generalists can move between all of that. Same with your cold. Same thing, temperature gradients, you can have somebody that moves between all of it. It's kind of the life history of the human. That's one reason that they're so successful. And you're also going to get a lot of different elements. You talk about the 6 elements of life, you get them here, and they have a cycling that you can basically see, that they go through all different phases, and it does not stay in one phase. It changes and moves throughout the lake ecosystem. And there are several of them. I got here the mercury, which basically, when you add sulfur to the mix, you're going to get mercury that'll turn into, not organic, starts out as organic, it'll methylate. So once it methylates, it'll be taken up by the fish. You eat the fish, you get to mercury. And mercury's not good because it's normally not found free in the environment, and life did not evolve with mercury. Otherwise, it would be okay. It's not okay because we didn't evolve with it. So that's really the story there. And then there's more of that. I'm running out of time. I'm gonna go until everybody walks out of me. So we have sulfate that basically, I got 50 more slides. No, I'm kidding. We got sulfate that actually combines with the mercury and methylates, and we have sulfur bank mine. We got a lot of sulfur. We got a lot of mercury from there. Guess what we have? A lot of methylated mercury. It's not rocket science unless, if you know all this stuff. The thing is, they don't study the right stuff. It makes me angry. And the other thing is, if you've got a coal burning plant, this is what it's about. Sulfur dioxide, nitrous oxide, you get it with rain, turns into acid rain, changes the pH of the lake, you lose the fish. There are hundreds, if not thousands, of dead lakes in Canada. And that's why our Canadian relationships were a little strained for a while, because we were burning so much coal. Nitrogen cycles, that's the same thing. It gets very complex. You got to have nitrogen cycle, but you got to understand it. And now, I wanted to get to this, and that's Scott Dam. So we're dam builders. Not necessarily bad, because there are natural dam builders that basically build ecosystems. If you do it right, you slow the water down, spread it out, move it down, move it into ponds, move it into little streams, move it so that things grow differently than they would somewhere else. Next thing you know, everything adapts to that, and you got critters everywhere. And so that is your hero right there. And so he basically made the Sierra Nevada and all of the coastline and all of the species. And once those guys started getting trapped out, things changed. And it's still adjusting from that change. And so that's why they wanted to bring them back. This guy here, you hear about mountain beaver, so I wanted to throw one in there so you can see what a mountain beaver looks like. Ain't a beaver. He digs holes in the side of banks, but he doesn't build dams. They basically are much like us. Humans are related to beavers because he's modifying his ecosystem to make life better for himself. So basically what they do is they build a mound. They got a hole down here where they can get in. They build a dam. It floods the hole. Now nobody can get in but him because he goes down, gets up inside, and right inside here is a little bench where all of the action takes place, and they build a new family, and they all come out until the food supply gets a little bit weak, and then the critters go on upstream to build another dam, and that's how they disperse. So, or something eats them. It's all in balance. So anyway, those are the guys that have built most of the West from the standpoint of slowing water down, building meadows, and every time you run a road through a meadow and it drains out and it gets dried, and you can't tell what it was you had. It's just gone. And so you have to see what it is that's happening. There's meadows around you think are not live, and they are. And you got to be careful. You got to, knowledge is not about what will make things better. It's lack of knowledge will make it worse. Now here's some critters in the lake you got to know about. This one here is the river otter, and see how they've adapted. They are good fisher persons. And that guy there is a mink, and you can tell a mink because they are challenged. They actually can move around so fast after their prey that lots of little things can't escape a mink. So that's how they make their living, much different than the river otter. We have a lot of them in the lake. We also have the ground squirrel, your favorite, and we have the tree squirrel that keeps trying to drop pine cones on us. Lots of these guys around right now. And then that guy there is the only marsupial in North America. But the rest of them are placenta mammals, and then that's the marsupial, and that's an escapee. Basically, they were brought out from Florida to raise, and they were turned loose. But now it's a native. We've taken it on.
They're good eating, right?
And yeah, they are. So this is all pictures of warblers. And the reason that I'm showing you a bunch of warblers is because warblers are a little like Darwin's finches. They have partitioned out on different areas of the trees, and then they've changed their colors to let everybody else know who they are. They're a different warbler. So I'm in the top part of the tree, you're in the bottom part. And so the warblers basically are everywhere, and there's a lot of different species, and they were driving me nuts trying to identify them. And some species have moved apart because there is so much difference in the habitats, not just north-south for breeding purposes, but I can make a better living here. I can make a better living here. I can make a better living here if I adapt to it. So species adapt to their environment. We adapt our environment to ourselves. And that's the basic difference. Just like the guy that builds the dam that puts everything behind it. So we're a lot like beavers. And I'm just about out of time. I'm going to get to hook. I wanted to show that another adaptation here is behavior. Family behaviors will take care of species. Case-selected species, they basically get the species for a longer period of time doing the right things until they get off onto their own. And so our California quail does that, and to watch them is just absolutely precious. And the male will sit up and post and make the sounds and all that. This is the mountain quail. We also have that. These little eggs are about the size of your thumbnail, and they're precious. The whole thing is real neat. You think that they're not going to last, but because of these behaviors, they're able to, the male will sit up there and check things out and gives a call, and everybody comes out and feeds. He gives a call, they shoot. And you ought to watch them do it. They'll scoot. The difference between birds are in their beaks. We look at it from the standpoint of being in their colors and all that sort of thing. They know the difference, but when they adapt to their feeding behaviors, and the beaks are what give them the advantage. And so look for the beak, and that's a big field of study. And then, of course, all kinds of different birds. You can identify them. All but one here is a native. What's that one there?
It's a yellow-headed
Right, yellow-headed blackbird,
Good job, Beth.
rosy finch, the other sex, rosy finch, warbler, yellow-back warbler, wren, mourning dove, California bluebird. Believe it or not, that's a yellow-shafted flickerer that is the same species as the red-shafted flicker we get locally. So as you go east, you get more yellow-shafted flickers and less red-shafted flickers. As you come out here, you got red-shafted flickers and an occasional yellow-shafted flicker. And the way to tell them apart, I'm going to quit here in a minute, is that little black beard right there. That's the yellow-shafted flicker. Yeah. That yellow-shafted flicker has a black beard. And so there's the Oregon junco, and you can see this is the only bird that walks with its head down the shaft. The rest of them will walk sideways like that and up, but that's the only one that'll turn around and walk straight down. Which one is that? Nuthatch. And it has 2 talons forward, 2 back, so that it can do that. It's the only one that does it.
What's it called?
And there's our karate bird. This is the Canocti karate bird. It's a true story. We have them. I have a picture of it right there. All you have to do to see the karate bird is put out a food dish, seed dish. And so these are the other birds that store grain. We also get this one. This is woody woodpecker. This is the model form. That is the pileated woodpecker, absolutely. The biggest woodpecker we have in North America. And then all these other guys are woodpeckers except the one down here. I thought it was going to be the one that wasn't the Anna's hummingbird, and it turned out it's not a local, but so I don't know which one that is. But with 95% of what you see is going to be an Anna's hummingbird. Otherwise, you got a few others that are around. And then you got the ladderback, you got the red-headed woodpecker, the acorn woodpecker, and look right underneath the, right there, that beard. It's red, it's not black. That is your red-shafted flicker. So that's the one that we have locally. And there we have, and I'm just showing, there is a ton of birds. They're everywhere. 350 species of birds in Lake County. We have niches and habitats on top of it here. This place is rich. If you want to basically sell Lake County and how what something of California is left behind is intact, this is the place to do it. And then you have, now I'm on my 5 last slides. So you have red-shouldered hawk, you've got the peregrine falcon, we have that locally, we have the red-legged hawk, and we have our friend over there. It reminds me of my old aunt with that look. And I swear to God, if you knew her. And of course, all these big birds of prey here, and this is the sharp-shinned hawk, and this is the harrier hawk, and they occur in the same area sometimes here. This is the only place I know of that happening. Over in this area, they say it can't happen. And of course, the one down here, you can thank PG&E for all of the osprey in Lake County, because they build a lot of these nests. And then the osprey has a habit of every time they catch a fish, they give them a ride so they can see where they're going. And that basically lowers the wind resistance, and they'll turn them around so that get the head going forward. Give them a look. And then we have, I got just about finished. We got the egrets, and we got the heron, and so that's the snowy egret, that's a common egret, or what do they call them now? Great egret. And this is called a cattle egret. If that's called a cattle egret, name this one.
Horse egret.
That's a horse egret, you're right. Okay, got 2 types of grebes. You know which ones they are. One's the Clark's grebe, the other is the western grebe. Yeah, the Clark shows his eye. So that's the Clark's grebe, and he's got a little bigger bill. And we have them both here. And the grebes are precious. They put their baby on the back. Why they do that? Did I tell you that we have bass in the lake? Yeah. And then you've got all of the breeding behaviors. And that one up in the right corner is the merganser. And so we have the beautiful dancing behavior. This pair will probably not mate. Why? Because they're out of step. It's precise. But I'll tell you what, That's a beautiful thing to see on this lake. And so is that a Clark's grebe or a western grebe? Western grebe. And so they do nest on floating nests. This was a couple of years ago. Terrible survival rate. Terrible. And it really concerns me because this year we don't get very many, and there was no one investigating why. There was a lot of disturbance of the nest they had a bass fishing tournament at the same time, and those guys were running through the nests and didn't know. Nobody said. And the signs weren't out, and there was a lot of kayakers out there, but I don't know that that's the case because nobody investigated this. But I went out and looked, and there was a lot of abandoned nests. And then we have all of our others. This is coloration, so that when the American bittern turns his head straight up, then he looks like part of the weeds back here. And then you got the green heron, the black-capped night heron, coloration so that they blend in. You got the kingfisher, all head, they go in, they can just dive right through the water because they're weighted forward. And then you got the double-breasted cormorant that can swim faster than the fish because they're not buoyant. And so that's why they hang their wings out in order to drain them dry again and get light enough so they can fly. And then when they dive into the water, they can go fast, but they're wet. And so when they get out, there's a lot of energy, and then they let them dry. That's that story. And then, of course, the duck populations, the loons and everybody, and then there's the ruddy duck that dies off every year because they pass diseases back and forth. And then we've had the Lake County Air Force. And we have, is that called a gaggle of pelicans? You know about murder crows. You know about gaggle of geese. What is it? I got another story to tell about this, but I can't because Bill back there wants to shut down. So this is a pod. A pod of pelicans. A pod of pelicans. Pod of pelicans. They have similar behaviors that whales have with their family members, and they call them a pod. And murder of crows, the way you tell crows apart from ravens is the tail. The little cutoff tail for the raven is more of a boat tail. Right here, you can tell by looking at the beak. One has a hairy beak and a bigger beak, and the fact that the ravens are about a third of the body weight higher. And we have all our introduced species. So here's our turkeys. We have the turkey that came over from Texas. This is the Texas turkey, the Rio Grande, and the one that doesn't have the bright tail around it is the Arizona turkey that didn't take off so well, but it's the Merriman, and you get them up in the higher elevations, and so they didn't do as well because the mountain lions could get to them. And anyway, they will roost up in the trees, and these guys, the peahens, will actually take up with the turkeys and be in the trees with them every once in a while and walk around with them. I see tracks all over the place with peahens. And if you ever walk out underneath these guys and they all of a sudden realize you're there and they take off, you will die because that is a lot of racket and it's absolutely amazing to watch. They scare the hell out of you. And then we got our invasive species here is the toad. That's the one that Mark Twain brought out and everybody else. So it's everywhere. And then that's the North American wild turkey range. The red is now over in California. It used to only be purple, which was from Arizona. And why do we try to bring in turkeys? Because it supports the sport industry, and the sport industry basically supports habitat throughout California. There's been more habitat saved from the Western onslaught by the sportsmen than any other group, including the environmentalists, especially the environmentalists that were anti-sportsmen. The fact is they have saved more, and I'll tell you, chapter and verse, you can find it anywhere. So they sold them a lot of sales, sporting goods, all that sort of thing. There's a portion of that tax goes to Pittman Roberts, I think it is. Yeah, it goes to habitats and all kinds of studies, that sort of thing. Plus the fact, after this guy gets up, he'll have to go to the doctors because he's sitting there with all the ticks. And then finally, this is my piece de resistance. You have all of the predator species here. Tell me the name of the owl. Long-eared owl in the center and burrowing owl up in the corner, and down here is the golden eagle. We have golden eagles so big in Lake County that, in fact, yes, you have to be careful of them. You can't go out at night. So if you think that is big, we also have eagles.
That's the one that got Donald Trump.
So that's my Lake County presentation for ecology for you.